So you hear it all the time, right? AGI is just around the corner any day now. But if you actually look at what the top AI labs are doing, their day-to-day work, their actions, seem to be telling a completely different story. So today, we're going to dig in and ask a simple question. What are we really scaling?
All right, let's dive right into what I'm calling the AGI contradiction. Because right now, there's this massive paradox at the heart of the entire AI industry, this huge gap between the hype and the reality on the ground. And here's the split. On one hand, you have the hype machine, right? The proclamations that these human-like general learning machines are imminent. But then you look at the actual actions, the day-to-day grind at the major labs, and what do you see? You see them painstakingly pre-baking really specific skills into models, teaching them how to use Excel or how to browse the web, one tedious task at a time.
This just begs a really important question. If these models are truly going to be able to learn for themselves on the job in this dynamic, self-directed way, then all this effort to pre-bake skills right now is basically a complete waste of time. So, which is it? Are the labs actually preparing for a future where AI learns on its own, or are they building for a future where it can only do what it's been explicitly and very painstakingly taught?
Okay, so this whole thing brings us to what's really the dominant strategy in AI at this very moment. And it's a method that, as we've said, we can call pre-baking, but it's a strategy that might be deeply flawed.
So what is pre-baking? Well, labs are using a technique called reinforcement learning, or RL, to try and build in all the useful skills a model might ever need, one by one, before it even gets out into the world. Now think about that. That is the complete opposite of how you and I learned, right? We don't need to be trained on every single piece of software we might ever encounter before we start a new job. We learn as we go.
You know, there's this great little anecdote about a biologist that just hits the nail on the head. Her job involves identifying these things called macrophage cells on slides. An AI researcher heard this and said, "Oh, that's easy. That's just an image classification problem." But in the real world, to make that work, you'd have to build an entire custom training pipeline just for that one lab's specific slides with their specific lighting and stains. It's not a general solution at all. It's a super clunky one-off fix for one tiny microtask. Human workers are so valuable precisely because we don't need them.
And this is such a brilliant point from Baron Millig. We tend to think of AI progress as just, smarter algorithms and more powerful computers. But what we don't see is that it's also powered by billions of dollars being spent on human experts, PhDs, doctors, who are manually creating the training data to teach these models very, very specific skills.
And you know where this flaw becomes most painfully obvious? Robotics. Look, the challenge isn't the hardware. A person can learn to operate a complex robot with just a little bit of training. The problem is the software. If we actually had a true, general, human-like learning algorithm, the field of robotics would pretty much be a solved problem by now. The fact that it isn't tells us we are missing that fundamental component.
So, if the current methods are so clunky, it leads to another big question. Why isn't AI creating more economic value yet? And this, my friends, brings us to a massive trillion-dollar reality check.
You know, some people argue that new technology just takes time to get adopted, but that argument doesn't really hold up here. A true AGI would spread like wildfire. Just imagine an employee that could read your company's entire Slack history in Google Drive in a few minutes and instantly learn from every other worker. It would be infinitely easier to onboard than any human. It would solve the incredibly expensive lemons problem in hiring, that risk of accidentally hiring someone who isn't a good fit.
And the size of the prize here is just staggering. The annual wages for knowledge workers across the entire globe adds up to tens of trillions of dollars. 20 trillion, to be more specific. If AI models really had AGI-level capabilities, this is the market they would be capturing right now. The reality? Well, current AI revenue isn't even in the same ballpark. It's not even in the same zip code. We're talking orders of magnitude smaller. This enormous gap between the potential value and the actual revenue is the clearest signal we have that the capabilities simply are not there yet. Okay, so I know what you might be thinking. Isn't this just moving the goalpost for what we call AGI? And you know what? Maybe it is. But maybe a little goalpost shifting is justified. Sure, we've solved some problems we used to think were the key to AGI, things like reasoning and few-shot learning. But the fact that there's been so little economic impact suggests our old definitions were probably too narrow. It's only rational to look at the new evidence and realize there's more to intelligence than we originally thought. So this brings us to the real technical heart of the argument. It's this critical difference between two very different paths that often get lumped together: scaling versus learning. Let's break these two ideas down.
On one side, you have pre-training scaling. That's just making the models bigger and feeding them more data. And that has followed this incredibly predictable trend, almost like a law of physics. The problem is, the prestige from that success is being used to justify hype for reinforcement learning scaling, which has no predictable trend at all. It's basically laundering the prestige from one area to hype up another.
And look, this isn't just a hunch. Researchers like Toby Ord have actually run the numbers, and they are wild. He estimates that you would need 1,000,000 times scale-up in this reinforcement learning compute just to get a similar performance boost to what we get from one big pre-training run. It is just a wildly inefficient path forward on its own.
So, if pre-baking all these skills into a model isn't the path to AGI, then what is? What does the real path forward actually look like? Well, it seems the real bottleneck, the thing we actually need to solve, isn't just about scaling up pre-training compute. It's about solving for continual learning. That is, the ability for an AI to learn from experience while it's working, robustly and efficiently, just like a person does. That seems to be the real missing piece of this whole puzzle. And this paints a really compelling vision for the future. It's not a single, giant, all-knowing AI. It's more like a hive mind. Imagine you have all these specialized AI agents deployed out in the real world, doing valuable jobs, learning from that hands-on experience, and then merging all of those unique learnings back into a central model so everyone benefits.
But, and this is a big but, this is not going to be a single singularity moment that happens overnight. Just think about in-context learning. GPT-3 showed how powerful that was way back in 2020. But here we are, years later, still refining it. Continual learning will almost certainly follow the same path. We'll get an initial breakthrough, and then it'll be followed by 5, maybe even 10 years of really hard work to iron out all the kinks.
This idea also helps explain why we really shouldn't expect one single lab to suddenly achieve some runaway, unstoppable advantage. The competition between these places is just too fierce. Top talent gets poached constantly, breakthroughs get reverse-engineered, and honestly, the San Francisco rumor mill alone ensures that big ideas spread way too quickly for any one company to keep a secret for long.
So when you boil it all down, the key takeaway is this. While we are making absolutely incredible progress scaling up raw compute, the path to the kind of intelligence that will actually transform our economy requires solving a fundamentally different and much harder problem. We are successfully scaling compute, for sure, but the real question is, are we actually scaling true understanding?